All right, let's get right into it. We're going to be talking about boiling chips. Now, I know, they look like just tiny, boring little pieces of rock. But trust me, they are the unsung heroes of pretty much every chemistry lab out there, and they prevent total chaos using some incredibly elegant physics.
So, picture this. You're heating up a super clean beaker of water. It's getting hotter and hotter, way past its boiling point, but nothing's happening. And then, all at once, bam! The whole thing just erupts violently.
You know, that crazy explosion actually has a name. It's called bumping, and it is a really serious hazard in a lab. But the solution isn't some big, complicated machine. Nope. It's a tiny, porous stone that completely tames this wild physical reaction. Okay, so to really understand why our little hero, the boiling chip, is so darn effective, we first have to meet the villain of our story. And that is a dangerous problem called superheating.
Superheating is just a state of pure tension. The liquid has all this energy, way more than enough to boil, but for some reason, it just can't. It's kind of like a dam holding back this enormous amount of thermal energy, just waiting to break.
And here's what it looks like when that dam finally breaks. The energy just builds and builds, right? There are no small bubbles to let off steam gently. Then, out of nowhere, a single massive vapor bubble forms all at once. It expands explosively, and it throws scalding hot liquid absolutely everywhere. So that brings up the big question, why is it so hard for that very first bubble to form anyway?
Well, the problem comes down to this microscopic force, like an invisible wall that makes creating a brand new bubble from nothing almost impossible.
And this villain, it has a name, the Laplace pressure barrier. Basically, a liquid surface tension acts like a really tight skin, and to create a new bubble, you have to push against that skin from the inside, which, it turns out, requires an incredible amount of pressure.
And here's where it gets really weird. It's a paradox. The physics tells us that the smaller a bubble is, the more pressure you need to keep it from collapsing. So think about it. To create a brand new bubble, which starts at a size of basically zero, you would theoretically need almost infinite pressure. The liquid just can't do it on its own. It's impossible.
So, if the liquid can't get past this pressure wall on its own, how do we solve the problem? Well, enter our hero, the boiling chip. Its secret weapon is its very structure.
I mean, it doesn't look like much, does it? Just a little piece of porous ceramic. But those tiny holes, those microscopic cavities, they're not a flaw. They are the entire point. They provide a pre-made, perfect little shelter for bubbles to be born.
And the specific shape of those cavities? It's everything. If you have a completely smooth surface, there's nowhere for bubbles to get started. That leads to dangerous bumping. If you have a pore that's too wide, well, it can't build up enough pressure. But the ideal chip has this perfect geometry, a small internal volume with a really narrow opening. And that's what sets the stage for the magic to happen.
This perfect geometry is what allows the boiling chip to defeat that Laplace pressure barrier in a brilliant three-stage takedown.
Okay, here's how it works. First, that tiny cavity traps a little bit of air in vapor, and it acts like a miniature pressure cooker. The pressure just skyrockets inside. Second, that immense pressure forces a high-speed jet of vapor out of the narrow opening. We're talking like a microscopic rocket engine. And finally, that focused jet just pierces the liquid's surface tension. It creates the seed, the nucleus, for a new bubble. So you see, it doesn't try to fight the pressure wall head-on. It just finds a clever way to puncture it.
And the result of this whole elegant mechanism? A complete transformation, from violent, chaotic bumping to smooth, controlled, gentle boiling.
You know, the speed and efficiency of this cycle is just incredible. The jet starts a bubble in the very first millisecond, then it grows for about 10 milliseconds, then it detaches and floats away. And almost immediately, that little cavity is reloaded and ready to fire again. It's a continuous, rapid-fire process.
And believe me, rapid fire is an understatement. This entire life cycle repeats between 10 and 100 times every single second for each one of those tiny little cavities. And that's what transforms a potential explosion into a smooth, gentle boil.
I mean, the difference is just staggering. Without a chip, a liquid can superheat by as much as 20 degrees Celsius. That is a huge amount of stored up, dangerous energy. But with a boiling chip, that superheating is practically eliminated. It stays under 1 degree. The danger is just gone.
And the numbers, they really tell the whole story here. The bubble rate goes from, maybe one violent eruption per second, to hundreds of gentle ones. But that last number, that's the real game changer. The energy needed to form a bubble is reduced by a factor of 1,000 to 1,000,000. Now that's the real magic. It's all about making it incredibly easy for bubbles to form.
So this means that not just any old porous rock is going to do the trick. No way. These chips are engineered with some incredible precision. The cavity and its opening have to be just the right size. We're talking measured in micrometers to optimize that pressure jet. The material can't react with anything, and the goal is to pack in as many of these perfect little cavities as possible.
Of course, boiling chips aren't the only solution out there. You could use something like a magnetic stirrer to just mechanically shake up the liquid. And yeah, it's reusable and it works under a vacuum, but it's also more complex. The true beauty of the boiling chip is just its elegant simplicity and how incredibly effective it is in most day-to-day situations.
So the fundamental insight here is really profound when you think about it. The boiling chip doesn't fight physics by trying to stop boiling. Instead, it works with physics. It creates the absolute perfect conditions for bubbles to form easily, gently, and continuously.
As the source material puts it just perfectly, the solution isn't about preventing bubble formation, it's about making it incredibly easy.
It's really just a masterful application of cavity physics and fluid dynamics. By understanding the forces at play, this simple-looking little chip turns a chaotic, dangerous process into one that's perfectly safe and predictable.
It's a beautiful reminder that sometimes the most profound science is hiding in the simplest objects around us. It really makes you wonder, doesn't it? What other elegant physics are we just completely overlooking every single day?